Good morning, 5B. Today is 30th of April, Thursday. Okay. Today is actually the last day of HBL because on Monday we will meet each other for Google Meet to just close up the whole full HBL period. Okay. So today is the last session, and today we'll just finish up the homework for yesterday as well as to carry out two activities for the effect of the number of bulbs connected in series or parallel, which you have learned yesterday, on the effect of the brightness of each bulb. Okay, so this SIN that we'll be discussing now is your homework yesterday. That you have went through a lesson on the number of bulbs, the different arrangement of the bulbs in a circuit that will affect the brightness of each bulb in the circuit. Okay, so there are two ways of connecting bulbs in a circuit. Either you connect them in series, which is what we're going to talk about now, and then later on we're going to talk about uh how they how it's different when they are connected in parallel. Okay, so when you have more bulbs connected in series in an electric circuit, each bulb in the electric circuit actually shines less brightly. Okay, actually shines less brightly. This one you will probably have seen it in the lesson yesterday through the animations. Okay, so when you connect the bulbs in series, when you add more and more bulbs in series to the circuit, each bulb will actually shine less bright. This because the amount of electric current, because the brightness of the bulb depends on the amount of electric current in the circuit. So when you have more bulbs added in series to the circuit, the amount of electric current flowing through each of them will be actually lesser. Okay, is decreased. Okay, all right, because in a sense the idea of sharing is there. When you have more uh bulbs connected in series, they are actually sharing the electric current. So each bulb is actually having less electric current flowing through them. That's why it becomes less bright. Okay, so with this concept, okay, let's look at the question below. So I have two circuits here. This is a very simple circuit, three batteries and one bulb. While on the other hand, for circuit D, you have two bulbs connected in series. Okay, as you realize, how do I know they are connected in series? I can actually trace out the circuit. So you realize that how do I know that D is connected in series? Again, there's only one path. Okay, there's only one path for the electric current to flow through. So for this, we know that the bulbs are connected in series. In series. Okay, so we know that this is the bulbs are connected in series, but this is just a normal circuit. All right, in a sense, because there's only one bulb and three batteries. Okay, so firstly they ask you for the arrangement of the batteries. But actually I don't want to talk about battery in this SIN over here. Actually I don't want to talk about battery, so please cancel out the word battery. Okay, I want you to talk about arrangement of the bulbs because this part of the SIN is talking about bulbs. Okay, so the arrangement of the bulbs in both circuits, they are connected in series. So let's write the answer down. Okay, they are connected in series. And how do I know they are connected in series? Because you realize there is only one path for the electric current to flow through. Okay, so how you identify series or parallel is really looking at a number of paths. There's only one path the electric current can pass through. It is a series. If they have multiple paths for the electric current to pass through, it is a parallel circuit or connected in parallel. So there is only one path for the electric current to flow through. Right. So they are all connected in series. For this case, there's only one path for the electric current to flow through. Okay. So the next one. Okay. So the next part, they're asking which bulb is brighter. Is it a one? Okay, hold on for a while. All right. So for part B, they're asking you which bulb is brighter. So let's choose the color. Okay. So which bulb is brighter? Is it the one in C or the one in D? Okay. So you realize that for this case, circuit C has only one bulb, all the electric current from the three batteries all flow through that bulb. While for circuit D, there's also three batteries, but these three batteries, the electric current flows through two bulbs. So in a sense, the electric current is shared between the two bulbs. Okay, so C, the bulb in C will definitely be brighter because all the electric current from these three batteries flows through this bulb, while for D, there is two bulbs sharing the electric current from the three batteries. Okay, so which bulb is brighter? The answer is the one in circuit C. Okay, the one in circuit C is brighter. Okay, the bulb in circuit C is brighter. And why so? Because they asked you to explain. Because the electric current from the three batteries provided by the three batteries flow through that one single bulb in C. Okay, and because of that, we know that electric current is not split or is not shared with other bulbs. Okay, so let's run through this explanation again. Okay, how do I know C is bright? A bulb in C is brighter than the bulbs in D because the electric current from the three batteries, which is the same for D, flows through the only bulb here in C. Okay, electric current is not shared with other bulbs because in D the electric current is shared between the two bulbs. That's why you have less electric current flowing through each bulb. That's why the brightness of the bulb in D is definitely less bright than in C. Okay, so the idea of sharing is here. The idea of sharing is just a way to understand this, but as you go on higher to secondary school, you will know another way of explaining. Okay, so just take it as the electric current is all going through this bulb in C, so it's brighter, while for bulb D, the electric current goes through two bulbs, is being shared, so the electric current going through each of them is lesser, becomes less bright. Okay, so let's look at the other way of connecting bulbs, which is connecting them in parallel. Alright, so the other way of connecting bulbs in a circuit is connecting them in parallel. So when there are more bulbs, okay, when there are more bulbs connected in parallel, so just now we talked about series, now we talk about parallel. So when there are more bulbs connected in parallel, the electric current flowing through them remains the same. Okay, I'll explain this later. Okay, so through the lesson yesterday, you realize that the electric current, if the bulbs are connected in parallel, the electric current flowing through them remains the same, and if the electric current flowing through them is the same, the brightness will also remain the same. Okay, alright, so we look at an example over here. You realize this is a pretty normal circuit with only one bulb, but there is actually two bulbs over here. And how do I know they are connected in parallel? So let's highlight. So you realize there are two different paths. So this is one path that the electric current can flow. You realize the electric current can also flow in this path. Okay, so there are two different paths the electric current can flow, and because there's two different paths, because there's more than one path for the electric current to flow, that's why we call them so we say they are connected in parallel. Okay, so let's answer the first part first. So again, what is the arrangement of the bulbs? Okay, the arrangement of the bulb is in parallel. And how do I know? Because there's more than one path for the electric current to flow. Okay, this is in F, so let's write in F first. In F, the bulbs are arranged in, okay, in F, the bulbs are arranged in parallel. Okay, in E, okay, in E is the normal way of arranging. There's only one path, so in E the bulbs are arranged in, the bulb is arranged in series. Okay, so I hope you can see the difference. You realize that for, okay, in F, okay, maybe let's write this down, okay, here would be better. Okay, so you realize that in F, because there's two paths for the electric current to flow, the bulbs are arranged in parallel. But in E, there's only one path. Okay, as we have said just now, there's only one path for the electric current to flow. See, there's only one path. So if there's only one path, the bulb is arranged in series. Okay, so let's explain why it's parallel. Okay, so the reason because, okay, let's maybe write over here, as there is more than one path, as there are two paths, or you can write two different paths the same for the electric current to flow. Okay, so for E is a series circuit connected in series because there's only one path, but for F the bulbs are arranged in parallel because there are two paths for the electric current to flow. Okay, so going back to how the brightness of the bulb can change when it's connected in parallel, you realize that yes, you will say that, hey, teacher, if the electric current flows through here, there's like a junction here, it will split. Okay, splitting is not the same as sharing. Okay, just now in uh bulbs connected in series, you realize they are sharing because the electric current has only one way to go. It has to go through two bulbs to get back to the battery. However, for parallel circuit, you realize it doesn't need to just go through that one path and go through another path. So in a sense, when it's a splitting, it's actually not sharing. Okay, it's different. To understand this deeper, you really have to go on to secondary school to know that actually what determines the brightness of the bulb is the potential difference between the two ends of the bulb, okay, which is determined by the battery. Okay, so but for now you just take it as when it's splitting, the electric current flowing through the two paths is still the same. Okay, but however, if they are connected in series like just now, the same electric current has to flow through two bulbs, which makes each bulb have less electric current flowing through them, makes it less bright. But on the other hand, if I have a junction over here, the electric current is not being shared, the same electric current flows through here, the same electric current flows through here. Okay, all right. Okay, so because the same electric current flows through this path and the same electric current flows through this path, the amount of bulb is going to be the amount of electric current flowing through them is the same here, here, and here, is all the same. Okay, so the brightness of the bulb will actually remain the same whether is it E or F. So the interesting part of connecting bulbs in parallel is that you get to maintain the brightness of the bulb without a drop. So you can connect 3, connect 4, connect 5 in parallel, you'll see that the brightness is the same. Alright, so question now, is the bulb in E brighter, dimmer, or the same brightness? It is actually the same brightness. The brightness is the same. Brightness is the same. Why is that so? Because very simple, brightness depends on electric current, because the electric current flowing through the two bulbs in circuit F, okay, because the electric current flowing through the two bulbs in circuit F is the same as the electric current flowing through the bulb in E. Okay, all right. So when you connect bulbs in parallel, the interesting thing is that the brightness will remain the same because the same amount of electric current flows through each path. Okay, there will be no drop in electric current. Okay, because it is, although it's split but it's not actually being shared, it's still the same amount of electric current passing through the bulb. That's why it's still the same brightness. Okay, so the brightness will remain the same because the electric current flowing through the two bulbs in F is the same as the electric current flowing through the bulb in E. Okay, so the last part, so now if I connect another bulb to circuit F, which is parallel to the two existing bulbs, so let's do that, let's draw it out. So what I'm saying here is, what if I join one more bulb that's parallel? So what if I put one more bulb over here that is parallel? So this is for part C. Okay, so for part C, if I connect a bulb in F that is parallel to the two existing bulbs, which is around here, will the brightness change? The answer is no. The brightness will still remain the same. Okay, so the brightness remains the same. Okay, the brightness remains the same. Why? Because again it is connected in parallel. Okay, as long as they're connected in parallel, the brightness of the bulb will remain the same because the same amount of electric current flows through them. Alright, so this is the SIN for yesterday. Now let's move on to the topical worksheet, the last two questions, question 14 and question 15. Right, so this is on electrical system, so it's about open closed circuit, conductors of electricity, and circuit diagrams. Okay, so let's start. Question 14, you have two circuits set up here, same type of battery, same type of bulb, but the key here is this, bulb 1 light up, not bulb 2. So bulb 1 light up, bulb 2 don't light up. So before we go on the question, understand this part first. Okay, so look at circuit 1, or look at this circuit. Battery connected to E, connected to bulb, connected to F. It's like a closed circuit, which is good. So it lights up. It means that E must be a conductor because it allows electric current to pass through. So this must be a conductor. And similarly, F must also be a conductor because it allows electric current to pass through. That's why the light bulb will light up. Okay, so I know both E and F are conductors. So you need to write it down so you can remind yourself. So if E is a conductor, means that over here in the second circuit, this E is also a conductor. So if E is a conductor here, means E is also a conductor here. It looks like a closed circuit, but why didn't it light up? Because E is a conductor, but G must be a insulator. So you have to understand the diagram before you answer the question. So there's a lot of understanding to do first, especially in P5 now. Okay, so over here again, once again, this can light up means E and F must be conductor. If this is a conductor, this must be a conductor as well. And because this doesn't light up, G must be an insulator. So over here, let's transfer our knowledge. We know that E must be a conductor. And then we know that G is an insulator. Okay, let's put it over here. Okay, we know G is an insulator. Okay, so based on the observation from the first setup, state whether the bulb in X will light up. So if this is an insulator, of course there won't be any electric current flowing through here because electric current won't flow through an insulator. So let's trace the current, see whether it will flow through. So I start with the battery. I know battery can flow through here. I don't need to go up to G because I know I can't. I can go through E and then go to the bulb, and the bulb can join back to the battery. So you realize it is a complete circuit, or what we call a closed circuit. And since it's a closed circuit, means the bulb can light up. Okay, so let's do our CER first. Okay, so over here. Okay, so the claim is yes, it can light up. Okay, so yes, it can light up because it is going to be a closed circuit. So let's look at the evidence. Okay, the evidence is what we can see from the diagram. Okay, we know that E must be a conductor based on the information given above. So we know that in setup 1, yes, correct, in the first setup, okay, we know that in the first setup, since the bulb can light up, because in setup 1 the bulb lights up, E must be a electrical conductor. Okay, so this is the evidence that we know from the first part of the diagram. Since the bulb in setup 1 can light up, E must be a electrical conductor. So how do I know that the bulb in X will also light up? Because since E is an electrical conductor, okay, it allows electricity to flow. Yeah, it allows electric current, sorry, to flow through it. And when electric current can flow through it, the circuit becomes a closed circuit, allowing the electric current to pass through the bulb. In X. Okay, so it's pretty long. So let's try to digest it first. Okay, so right. So from on top we know that E is electrical conductor, and once we know E is electrical conductor here, it must be an electrical conductor also here. So yes, G is the insulator, electric current can pass through here, but in order for the bulb to light up, as long as the electric current can flow through it, as long as a closed circuit, it can work. So we realize that hey, E is a conductor, it can conduct electricity, and then it forms a closed circuit. So the reason here is very simple. Yes, it lights up, because in the first circuit, it is shown that E is an electrical conductor because the bulb lights up, and since it is an electrical conductor, it allows electricity or electric current to flow through it. The circuit becomes a closed circuit in X, allowing the electric current to pass through the bulb in X. That's why the bulb lights up. Okay, so let's write this in sentence form. Okay, I'll pause the video here for a while. Alright, so I have typed it out. So let's run through. So will the bulb in X light up? Yes, it will light up. Why? Because E must be an electrical conductor since the bulb in the first setup lights up. So if it is an electrical conductor, it will be here as well. It will allow electric current to flow through it, and since it allows electric current to flow through it, it becomes a closed circuit. It allows the electric current to flow through the bulb in X, therefore it gets light up. Okay, so one leads to another, E being a conductor means that it can allow electricity to pass through, means it becomes a closed circuit. In X means that electric current can also flow through the bulb, therefore the bulb lights up. So you have to be able to link from one small point to another small point to another small point. Okay, so there's a lot of copy, so you might want to pause the video and then look at it and copy it and listen again to hear about the explanation. Okay, now we go to the last question. Okay, so I have question 15. Tungsten is the material used in a filament of a bulb. Okay, so this is a tungsten, and we know tungsten must be a conductor of electricity, or else the bulb won't light up in a sense. Okay, electric current must pass through the tungsten wire in the bulb. So this is a conductor, but in addition, I'm gonna call it a poor conductor because tungsten is a poor conductor, but still a conductor of electricity. Okay, so poor electrical conductor. Okay, poor electrical conductor. That's for tungsten. Okay, so what happens is that you realize there seems to be a gap here. Okay, there seems to be a, let's use another color. There seems to be a gap here because you realize that the electric current from the battery can flow through the tungsten wire, go up to here, and then there's a gap here, and then if the switch is closed, probably can go through here. But the question here is that there is a gap over here that is filled up with liquid G. So when the switch is closed, so now when I close the switch, the tungsten wire became red hot and started to glow. And what does this mean? This means that electric current is passing through it. Okay. So the idea here is trying to tell you that the electric current is passing through the tungsten wire means it is a closed circuit. Okay, so being red hot and glowing means electric current is passing through it, means it is a closed circuit. Okay, maybe let's just make sure you know. Just write it down, becomes a closed circuit. So this, although there's a gap in the circuit, which is this part over here, when I close it, the electric current still pass through the wire, means that this liquid is a electrical conductor. Okay, so it is an electrical conductor. Okay, so once again, let me explain how do I know that it's an electrical conductors. Because when I close the circuit, I know that electric current passed through the circuit because the tungsten wire became red hot and glow. Okay, if there's no electric current passing through the tungsten wire, it won't turn red, it won't glow like your light bulb. Okay, so once I close the circuit, I know there is a complete circuit, there is a closed circuit. So which means that the electric current can pass from one rod to the other rod through the liquid G. Since electric current can pass through liquid G, means that liquid G must be a electrical conductor. Okay, because electric current can go from one rod to the next rod to form the complete circuit, means that the G must be a electrical conductor. Right? So now I change something. I change the rods. I make it to become ceramic rods. So ask yourself, what is ceramic rods? Ceramic rods are non-metal, and we know non-metals are non electrical insulators. And we right over here, you can see everything. Okay, all right. Okay, so now instead of metal rods, I use ceramic rods, and I know ceramic rods are non-metal. Non-metals are electrical insulators. I didn't change anything else, but you realize that the tungsten stops glowing, means there's no electric current passing through it. Why so? So straightforward. Ceramic is a electrical insulator. Okay, and what does it mean by being an electrical insulator? Okay, mean okay, which do not allow electric current to pass through. Okay, so if I change to ceramic rods, the ceramic is an electrical insulator. It doesn't allow electric current to pass through. Okay, so it will be an open circuit because there's a gap there now. So, and no electric current will flow through the bulb. Not through the tungsten wire. Right, so let's look at it again. You realize that the metal rods now change to ceramic rods, and ceramic rods we know is a non-metal, it's an insulator. So ceramic is an electrical insulator. They do not allow electric current to pass through. So what happens that it becomes an open circuit because there's a gap in the circuit already, and no electric current will be able to flow through the tungsten wire, okay, to make it glow and make it hot. Okay, so once you change the rods to become a non-metal, it becomes an insulator, no electric current can pass through. Becomes open wire, no electric current can pass through the tungsten wire. Okay, so this is question 14 and 15. This is the end of your topical worksheet for electrical systems. So the second part of the lesson today is for you to go online, use the online construction kit to carry out activity 6.2, which is arranging bulbs in series, and also conduct activity 6.3, which is arranging bulbs in parallel, and see for yourself the difference when the bulbs are connected in series and the bulbs are connected in parallel on the brightness of each bulb. Okay, I will give you some instructions on that. So I'll see you in the next part of the lesson.